Hello, welcome back to another video where today, as said in the last video, I found this homework question very interesting and I really wanted to show you this because it showed my favorite integration technique in this question. So here we're solving for a differential equation. We're solving for I of t for this differential equation right here. Now, over here we have a condition where 1 over c is equal to 0. So this we know is equal to 0, so we can rewrite this as v is equal to L di dt plus Ri, and that's it. Now, we have v is equal to v cosine omega t, so, or v naught cosine omega t is equal to L di dt plus Ri. Now, we're going to try to get this in its form where we can find an integrating factor to find an integrating factor. So we're going to divide everything by L, so we have a v naught over L times cosine omega t. We're going to divide everything by L, 1 over L. That is equal to di dt plus R over L times I. And now we're going to find our integrating factor, where our integrating factor is equal to e to the integral of R over L dt. Now this is just equal to e to the RL t, so we'll have the differential equation e to the RL t, which I'm going to keep it like that actually, times v naught over L cosine omega t is equal to our differential right here, which we have a di, or a ddt of our function I, and a mu naught, mu, which is e to the RL t. And now we're just going to integrate both sides with respect to t. So we're going to do this as v naught over L times e to the RL over times t times cosine omega t dt. Integrate that is equal to the integral of d dt ie times RL t dt, and obviously over here this integral cancels out and we just get back the function I e to the RL t is equal to v naught over L times the integral of e to the RL t times cosine omega t dt. And now you can see why I love this question. So now we have a cosine over here, so I'm just going to set this equal to j. So j is this integral over here. This whole thing is j. So we have j is equal to v naught over L times the integral of e to the RL t cosine omega t dt. So we're going to have the real part of v naught over L times the integral of e to the RLT, and now the real part of, cosine omega t is the real part of e to the IWT dt. And then we can combine that to get the real part of v naught over L times the integral of e to the RLT plus I omega t. I don't know if I said W, I meant to say omega. And now, same thing as last time, we're going to have a t times R over L plus IW. And then that, we're just going to take that down, and we're going to have the real part, V over L. We're going to do the integral of E, which is just a 1 over R over L plus I omega times E to the RL t plus IWT Now, once again, we're gonna wait until we do the plus c as usual. So we're gonna leave that off for now. So now we're gonna have multiply this L through. So we're just gonna end up with a V naught. Sorry, we're gonna end up with the real part of R plus I omega L times V naught times e to the R L T times e to the I omega T. And now e to the I omega T is the same. Oh wait, first before we do that, I'm jumping the gun. So the complex conjugate of R plus I omega L is R minus I omega L. So here we have an R squared, then we have a plus R I omega L minus R I omega L, which obviously cancel out, and then we have a minus I omega L squared, which this I becomes a -1, so this is a positive omega L squared. So we have the real part of V naught times R minus I omega L times, or over, sorry, R squared plus omega L squared times e to the R L T times e to the I omega T. And now we're going to expand this, but first we're going to do the real part of V naught times e to the R L T over R squared plus omega L squared. And that is a R minus I omega L times cosine omega T plus I sine omega T. And now we have an R cosine omega T. Since we only want the real part, I'm only going to worry about the R for the cosine and then this part for the sine. So then we're going to have a minus I squared omega L sine omega T, which this will become a plus and this will go away. It becomes a 1. And then we're left with the real part, which is just this as what we worried with. We have I over e to the R L T is equal to V naught times R squared plus omega L squared times cosine, sorry, not cosine, R cosine omega T plus omega L sine omega T, and then times e to the R L T, and then obviously we divide both sides, and we get our final answer, which is I of T is equal to V naught R over R squared plus omega L squared cosine omega T plus V naught omega L over R squared plus omega L squared sine of omega T. I also forgot to add the plus C over here, and we're going to add this to the end, which is e to the RL over T. And then we get the plus C times e to the negative RL T. And that is your final answer. Your current function of T is equal to V naught R over R squared plus omega L squared times cosine omega T plus V naught times omega L over R squared plus omega L squared times sine omega T plus C to the negative R over L times T. This was a really fun differential equation to do, just mainly because of the integration by imagination, which I really love. And if you saw my last video, you would know that I really like to get ahead of myself on this, especially when it comes to something I really enjoy doing. So if I ended up doing something incorrect and it looked wrong, let me know, and I could probably check it out in the comments. But yeah, so that would be the answer to this differential equation when 1 over c is equal to 0. and V is equal to V naught times cosine omega t. So if you enjoyed that video, please leave a like and let me know. And I'll see you guys on the next one. Bye.